My name is Husna from Sri Venkateshwara College of Engineering. Before starting topic, please like, subscribe my YouTube channel. Today's topic is abstracting learning methods for stacks and queues data structures in video games. Shall we start from abstract? Stacks and queues are fundamental data structures in computer science, frequently used in managing dynamics, ordered collection of data. In the video game development, these structures are essential for implementing various in-game systems such as event handling, game state management, artificial intelligence, decision making, and resource handling. The primary objective is to present a framework that allows learners to not only understand the theoretical concept behind stacks and queues but also to apply them in practical and interactive game development scenario. Next is introduction. Stacks in video games. Undo mechanisms. Many games offers an undo feature. Example, strategic games or puzzles, where a player can revert the last action. This is implemented using a stack where each action is pushed to the stack and popped when an undo is triggered. Queues in video games. Event handling. Queues are used to manage events like users' inputs or in-game triggers. For instance, in multiple games, the sequence of player input can be queued up to ensure fairness and order of execution. Literative review. Teaching data structures. Traditional approaches. Traditional education. Approaches to teaching data structures such as stacks and queues often emphasize formal definition, algorithmic complexity, and abstract coding exercise. Several studies have explored alternative ways to teach data structures in order to improve student engagement and understanding. Bennigsen and Carperson 2007 emphasized the importance of visualization tools for teaching abstract data structures, arguing that such tools allow students to see how their code interact with data in real time. Other works such as Sarva et al. 2013 explore the use of visual programming environments and interactive stimulations to teach algorithmic thinking. Game-based learning and engagement. The concept of game-based learning has gained the traction in recent years as an effective pedagogical tool, particularly in computer science. Research by Gee 2003 and Prinsky 2001 suggests that games can significantly enhance learning by making abstract concepts more tangible and engaging. Architectural model. Stacks in video games. Architectural models. In a video game architecture, the data structure can be integrated into different layers and concepts, often influencing system behavior in a last in first out LIFO manner. In architectural model that use a layer architecture or model view controller structure, stacks are used to manage game states such as menus, submenus, and gameplay scenes. A stacks of game states allow easy transition between scenes, enabling the users to navigate backward LIFO behavior. For example, when a player exits a submenu back to a main menu. Queues in video games. Architectural model. Queues function on a first in first out FIFO basis and are essential in managing real-time events and sequential operation. Within a game architecture, queues are crucial for managing tasks in a fair and ordered manner. Abstract learning methods of queues in video games architecture include event handling and input queues. In the event-driven architecture model, a queue can be used to manage user input, network events, or in-game triggers. These events are queued in the order they occur, ensuring that the system processes them one by one. Methodological principles applied to stacks and queues. Abstraction layers. Both stacks and queues are abstract into different layers of architecture. For stacks, this might involve abstracting game states an event within the business logic and presentation layer. For queues, this is more prominent in the event handling layer or network layer. Result. By abstracting the player's action into a stack, the result is a flexible system that allows player to revert, undo or redo their decision. This is particularly useful in games where tragical decision making or creation tools or keys such as in strategy or puzzle game. Queues ensure that game events such as player inputs, in-game triggers and AI actions are handled in the correct order. This leads to smoother gameplay, especially in real-time and multiplayer environment by preventing input lag and missed action. Conclusion. Stack abstract recursive stacks like AI decision making and pathfinding. Example, the depth first search. Learning how to implement these recursive process within game architecture results in more efficient handling of complex algorithms that require back tracking or exploration of multiple paths. Abstract learning of queues allows developers to schedule game tasks such as rendering, physics updates, or network data processing, ensuring tasks are completed in the order they arrive. This leads to better resource management and system efficiency, especially in high performance or multiplayer environment.